Solving quadratic inequalities. I'm getting this from Cambridge exercise 2D. So, to solve quadratic inequalities, what is a quadratic inequality? It's an x squared type graph with a greater than or equal, less than or equal. You can't solve it like a linear inequality. So, for example, this is a linear inequality, something like this. 2x minus 7 is greater than or equal to 3, that's a linear inequality. We know how to solve that, okay? So to solve this, what do you do with this? You just go to, how do you solve this? So you just move, 2x is greater than or equal to 10, x is greater than or equal to 5, and I could do one with a negative. So let's go 5 minus 3x is less than, 2. How would we solve this one? If I take the 5 over, it would be negative 3x is less than 2. Take away 5. Negative 3x is less than negative 3. Now what do I do with this? So here's where so you divide by negative 3 by the coefficient of the x. So we're dividing by negative 3, but what do I do when I divide by the negative? I have to flip the inequality sign. So I'm dividing by a negative, but because I'm dividing or multiplying by a negative, I must flip the inequality sign. I should have chosen another value where it wasn't just 3, but it's okay. So x is greater than 1. So they are linear inequalities. We're not doing linear inequalities. Just reviewing what you've done before, because it is good revision, you may see something like this. Do you remember how to solve these? This is an absolute value inequality. Well, the best way, because see, absolute value means distance from the origin. I think the best way to do these, absolute value means distance from the origin. So before I solve this, if I show you absolute value of x is less than 2, this means the following. I've got negative 2, 2, 0. Oh, let me make it less than or equal to, and I can colour it in. So that was linear inequality. This is still linear inequality, but I thought we'd review absolute value ones. So if I've got, I'm not doing that yet, but if I've got that the absolute value of x is less than or equal to 2, that means that x is less than or equal to 2 units from the origin. So absolute value means distance from the origin. So how would this is absolute value of x is less than or equal to 2. How do I express that without the absolute value? I would say that x lies between negative 2 and 2. So absolute value of x is less than or equal to 2 actually means this, that the distance of x from the origin, can we write that? Distance of x from the origin is less than or equal to 2 units. That's what that means. Now, you know how you want to do a plus or minus? I just do that for the equal scenario, not for the less than scenario, for the inequality scenario. So, when you were saying do one positive, do one negative, you do that when it's equal. But for inequalities, you need to set up an inequality statement. So if I just had that, my inequality statement is x lies between negative 2 and 2, because absolute value means, so absolute value is interpreted as, or is the distance of x from the origin. That's how, whenever you see it, that's how you say it. So this means that the distance of 2x minus 5 from the origin is less than 2. So see how I've gone and put my x in here? What am I going to do for this one? Now I don't have an x less than or equal to 2. I've got this is less than 2. So how do I write a statement like this? That 2x minus 5 is less than 2 units from the origin. So you could go 2 units to the left of the origin or 2 units to the right of the origin. So the way you write this one is like that. That 2x minus 5, absolute value, distance from the origin. So the distance of 2x minus 5 from the origin is less than 2 units. So you could go 2 units to the left or 2 units to the right. Open hole. So now how do I solve this? Anyone? All right, do we get what I'm doing? So I'm going to do a less than and I'm going to do a greater than 1. Now what you do is the same thing to everything. I need to get x on its own. What would I do first? Get rid of the 5. So I add 5 to everything. Add 5 in the 3 places. Negative 2 plus 5 is 3. The minus 5 plus 5 goes. And 2 plus 5 is 7. And now what do? Divide everything by? Divide by 2. Divide everything by 2, and it's a positive 2. I will do one with a negative in a minute. All right, so I've got that. So x lies between 1.5 and 3.5. All good? You can check it. Give me a value between 1.5. So let's check. Give me a value between 1.5 and 3.5. It can be a whole number. You can do 2 or 3. X is 2. So when you put x is 2 in here, 2 times 2 minus 5. What do you get? I'll just put it in, and 4 minus 5, that's negative 1. Absolute value of negative 1 is 1. That's true. Right? But if I tried something like x is 5, that won't work. So if x is 5, what would you get? 10 minus 5 is 5. Absolute value of 5 is 5. 5 is less than 2. Not true. Do you want me to show how the other one doesn't work? So if I did x is 5, this one should be not true. 2 times 5 minus 5 is less than 2. Let's see if this is true. 10 minus 5, that's absolute value of 5 is less than 2. That's false. So we can see why x is 5 is not a solution. That the solution lies between 1.5 and 3.5. All good? Right. Another one with a greater than or equal to, and I'll put a negative in there. So why don't we do this one? Absolute value of 3 minus 4x is greater than or equal to 5. Now, remember, absolute value means the distance of this expression from the origin. So if I give you absolute value of x is greater than or equal to 5, how do I draw this on my graph? What are the solutions to that? So can I move down from this one now? Before I do this, I'm going to just do the simple one. Absolute value of x is greater than or equal to 5. That means the distance. What does it mean? That the distance of x from the origin is greater than or equal to 5 units. So where do I put my inequalities? So none of this, let's go positive, let's go negative. No, you interpret absolute value as the distance from the origin. Come on, I'm going to put circles here. Tell me which ways to put my arrows. Out. See, because the distance of x is indicated by my circle and arrows, it's greater than 5 units from the origin. The origin is 0. Okay, so I'm going to do the same thing here. This expression is greater than or equal to 5 units from the origin. So I have to write up 2 equations. So look, this one up here is 2 equations, but look, if I put my finger here, look at the first one. There's one inequality, and here's the other inequality. Can you see? This is actually 2 inequalities, but combined. But whenever you've got a less than with an inequality, it's between 2 values because the distance is less than 2 units from the origin. Here I will have 2 separate inequalities this time. So I go 3 minus 4x, have a look over here, is greater than or equal to 5, or the distance of this is 5 or more units from the origin. So I go greater than or equal to 5, or I say 3 minus 4x is, how do I do this one? More than 5 units from the origin, up. So there's the origin, 5 or more units from the origin, 5 or more units from the origin downwards. What am I going to write here? Greater or less than? Less than or equal to negative 5. This expression is 5 or more units from the origin. So you can go 5 units up from the origin out, 5 units down from the origin out. Okay, so now you just solve each of these individually. So I'm just going to keep the 4x here just to show 5 minus 3 is 2. And what am I going to divide by? Divide by -4. So I have to flip the inequality sign. X is less than or equal to -1/2. And the other one, I'm going to do the other one the other way. So if you don't like dividing by the negative with your inequality, you can pick up and take terms over to the other side. So I'm going to go keep the 3 here, bring the 5 over. What do I get? 3 what? I want to take the 4x over to the other side. So what do I get if I take the 5 over? 5. 3 plus 5. Positive or negative 4x when I take it over? Positive. So I get 4x is greater than or equal to 8, because I'm reading like that. 4x, big open mouth facing 4x. It's greater than or equal to 8. See, now I just divide by 2. Do I change? I don't need to change the inequality sign for that. Now when I'm finished, I just turn it around. X is greater than or equal to 2. So that's if you decide to put your pronumeral on the right. Or you could have just solved like this. 3 minus 4x is less than or equal to -5. All right, let's keep the -4x there. I've got -5 minus 3 is -8. Now I have to divide by -4, so I turn the inequality sign. As soon as I bring the 4 over, I turn the inequality sign around at this step. I don't leave it and then change it on this step. I'm already dividing by 4 here, and I get x is greater than or equal to 2. So it's up to you which way you solve that second one. So we've got two solutions. X is less than or equal to 1/2, or x is greater than or equal to 2. You can have a quick sketch. Let's look at x is 5, 4, x is 4, 3 minus 16, that's -13. Absolute value of that is 13, is greater than or equal to 5. Great. Give me a value here that I could try. Check. Yeah, x is -1. 3 minus 4 times -1. So 3 plus 4. 7 is greater than or equal to 5. So all good, okay? So are we good? 7. And that's good. And this one we did 1 as well. So that is, so what have we got so far? We've got linear inequality, inequalities with absolute value. They're a linear inequality as well, because there's no x squared or x cubed. It's an example of a quadratic inequality. This is an example of a quadratic inequality. Does it make sense to you why it would be called a quadratic inequality? It's got an x squared and a greater than or less than or the equal signs. Right, to solve those, these are the steps. Steps to solve. You must move everything to the left-hand side. To the left-hand side and factorize. Then you will sketch the graph of y equals the left-hand side showing the x-intercepts. And then you just read the solution off from the graph. Now look, other people like to sketch it and start testing points. I think that's a long way. I really don't like it. I think this is the best method. So read the solution off the graph. Now, people that have done extension may have done this already, okay? Solve this first example up here. So x squared is greater than 9. So first step is to move everything to the left-hand side and factorize. So this would be x squared. What would it be if I'm moving everything to the left? Minus 9 is greater than 0. And how do I factorize that? Because that's a difference of two squares. A minus b, a plus b. Then it says sketch the graph of y equals the left-hand side showing the x-intercept. So now what we're going to do is sketch y equals this. Or that. Same thing. Now you describe it to me. What type of parabola? It's a parabola. Is it concave up or down? And where are the x-intercepts? Oh, let me just write where the x-intercepts are. They are equal to 3 and -3. So it's definitely concave up. So we know that it's definitely concave up. And x-intercepts are -3 and 3. So all you've got to do is move everything over to the right-hand side, sketch it, and now you just read. I'm not interested in where the y-intercept, it doesn't matter where it is, but it is -9 if you want to draw it, but you don't need it. Actually, sometimes I just draw the x-axis in for this. I don't even put the y-axis in. So if I look at this graph, see, where are the y values positive in this graph? Let's look at some points. This might be the point 1, -8. This, for example, is the point 2, -5. Can you see the y values are negative here? I need to know where this graph has positive y values. So where is this graph positive, greater than 0? Now, when I say where is this graph greater than 0, it's where are the y values for this graph greater than 0. So where is this graph above the x-axis? So if I look at this graph here, if I just, can you just highlight these bits here in blue? These are the bits that are above the x-axis. Right? In pink, down here, these are the bits of the graph that have negative y values. Do you get what I'm doing? And if I get another color and put some dots there, these are the values of y that are equal to 0. So I've got 3 sections. Where it's blue, y is greater than 0. Where it's black on the axis, that's the x-axis. So here I've got that y is greater than 0 in this top section. Here the y values are less than 0, and on the x-axis I've got that y values are equal to 0. So now you want to sketch where this graph is greater than 0, you just read it off. But for what x values is the graph greater than 0? So what's my solution? So where is this? I've sketched it. Where is it greater than 0? So which x values?
X is less than -3.
Yeah, x is less than -3. X is greater than 3. It's the blue section. The blue section is where the graph is greater than 0. All right, so we're going to do some that are above. We're going to do some that are below. See, when you solve that equals 0, you're just giving me the -3 and the 3. When you solve a normal quadratic function, you're just giving me x is -3 and 3. This time, by drawing the graph, you can physically see where is this curve above, where does it have positive y values. So see, if x was 4, x is 5, x is -4. That's where you get positive y values. So that's how we solve quadratic inequalities. You must do all those steps. So let's look at the second example from up above. X plus 6 is less than or equal to x squared. Now I'm going to do this one 2 ways. Still the same method, but it depends on which side you decide to take everything to. So let's take, which side do we want to go? Look, we can take everything over. I'd like to keep the x squared positive. I think it's the safest thing to do, unless you want to start factorizing with negative x squared. So if you decide to take everything over to the left, you're going to have to start factorizing with negative x squared. Look, we can do it that way, but let's take everything over to the right this time. So I'd have x squared. What else? So I'm going to take everything to the right. It doesn't matter whether it's the left or the right. Once I'm finished, I'll swap sides. I want to keep x squared positive, but now bring the x over, bring the 6 over. What do I get? Minus x. So now that that's written like that, it really is x squared minus x minus 6. Do I put a greater than or a less than? Pointy bit is facing the x squared. Open mouth is facing the 0. So I want to factorize this. So now this is the first step. Take everything over to the left-hand side and factorize. X what? Now I will put it the other way. I'll do it the other way if everyone decided to take to the left, and you'll see what happens. We'll get the same answer. I think, yes, take away 3 plus 2. So that's, what are my x-intercepts? They are x is 3 and negative 2. So now I sketch it. Just a quick sketch, doesn't have to be perfect. You don't have to show the y-intercept. It looks like this. So this is the curve. Now, again, where it's blue is above, and where it's pink is below. You don't have to do the shading, but... And we're on the line, it's equal 0. That's where y equals 0. Up here, y is greater than 0. Down here, y values are less than 0. So now let's solve our inequality. We've drawn the parabola. Where is the parabola less than or equal to 0? You just read it off the graph. It's the pink section with the dots because it's less than or equal to. So what's my solution? How do I describe these x values? Negative 2 is less than or equal to x because look at the original. It's a greater than, like less than or equal to, less than or equal to 3. So we want the less than, that's below, but we also want the equal. So it actually includes the points negative 2 and negative 3 this time. Yes. So this expression, so remember you're sketching y equals x squared minus x minus 6. So you want where y is 0 or less than 0. Yeah. So you want this to be less underneath, but also equal to 0. It's equal to 0 on the axis.
So the same sign that's here.
Yes, the same sign. Well, the same sign that you see written here. So in the factorized form, where is this below the x-axis? Where does it have negative y values? See, the value of this has to be less than or equal to 0. The value of this, when you work out the value of that, you're getting y. So where is the curve below the x-axis? And you need the x-axis values as well. So see how this is less than or equal to 0. Y would have been in place of that 0. Now, let's say you're doing method 2, example 2, and you've decided I've got to take everything over to the left because that's what the rule says. Take everything over to the left. But I'm telling you now, just keep x squared positive, it's much better. But let's take it over anyway. Other method. Same method, but, you know, with negatives, which I don't like. X plus 6 minus x squared is greater than or equal to 0, right? Isn't this then negative x squared plus x plus 6? What you could do if you want to do this is take out the negative and then factorize. You okay with that? Be careful if you're going to do this, right? So you okay? So I'm showing you another method of doing this. Let's say you decided to take everything over to the left. Now you've got a negative x squared. We really don't want to be factorizing that. I mean, you can. I prefer to take the negative out. Are you okay with taking the negative out, putting a bracket, and now that's all, the x squared is positive. But you still have to do this factorization like you did before. But when you sketch that curve, now that is this. It's the same thing. Do I draw it upside down? Do I draw it, is it concave down or up? That's what I'm trying to say. It still cuts at negative 2 and 3, but is it concave up or down? The parabola I've formed here. Down, so you have to draw it down. Right? But it's asking you, where is this parabola that you've drawn? It's definitely concave down because you've got negative x squared. But it's asking you, where is this parabola? Above or below? Above. Where is it above? Here. So it's the same. I'm doing the same question 2 different ways. So you just have to follow what you've got there. So this is where it's below. In blue is where it's above, and on the line is where it's equal. So because you've taken everything over to the left and factorized by pulling out the negative, you have to draw a concave down parabola. Do you get that? So I draw a concave down parabola. Where is my parabola? Above, greater than 0, above the x-axis. in the blue section plus the intercepts themselves. So I'm going from -2 to 3. All right? Now, if you don't want this thing happening, always keep your x squared term positive if you don't want this to happen. So this is for someone that says, I have to take it to the left. Take it over. All right, I've just changed the order. I've taken out the negative. And so now that's negative, and that's negative. I've factorized, but I've still got a negative out the front. All of these lines are the same. It's actually the top parabola here, so it is concave down. And the x-intercepts are 3 and -2. Okay, so you have to draw it down. But now where is this parabola above or equal to the line, the x-axis? Still got the same answer as before, but one's drawn with a concave down parabola and the other one's drawn with a concave up parabola. It depends which way you decide to take your terms. So if you always want concave up parabolas, just make sure your x squared's positive and take everything over that side. But if you do that, you've got to be careful here that the open mouth is facing the 0. So when you write this on the left and that on the right, as long as the pointy bit is facing the x squared, the pointy bit of the inequality, and the open part of the inequality is facing the 0. Okay? All right, we'll do a couple more. Do this. X is greater than plus or minus 3. Because what are your answers? X is greater than 3. X is greater than -3. What are the actual... So, like I said, if you do it this way, one of them will be right and one of them will be wrong. So X is greater than 3 is correct. But X is greater than -3 is incorrect. So if you do it that way, one of them will be wrong. Look, there is another method to do it. It is just to solve it with =9 and start testing points on either side. But look, I like to draw it. I like to draw it because you don't have to test anything. Everything works when you draw it. Okay? Squared term first, x squared minus 7x plus 10. Just easier to factorize when you're looking at it like that. Plus or minus x plus minus what?
-5 and -2.
All right, so this x-intercepts are 5 and 2. Draw it. Is it concave up or down? Up, 2 and 5. And don't worry about the y-intercept. We're not interested in that. So what are you looking for? Where is this curve? Above, below, where? Below and equal. So the x values where it's below are from 2 to 5. Nice and easy. On the line equal, below the line less than, above the line is greater than. We don't want greater than, we want less than or equal to. Okay, the next one, I would, if I were you, you've got two choices. You can pull the negative out at the beginning, or you can take everything over to the right and make it all positive and always draw a concave up parabola. What's it going to be? Let's take everything over to the right. So you've got 2x squared over to the right. Take away 9x. Take away 35. If that was over to the right, do you want me to write it like, what? Can I now put that that would be less than 0? Would you be okay with that? Because if that goes over there, the pointy bit is facing the 2x squared. Or you can put, if you want, are you okay turning it around in the one step or not? So this would be this. So I'll do an extra step. I would go 0 is greater than 2x squared minus 9x minus 35. That's what that would be. So when I take everything over to the right, I've actually got nothing left on the left, but I've still got the greater than. And then from there, I now write it that way. Do you see that? 2x squared, pointy bit, 0 has the big open, 0 is greater than that, 0 is greater than that. And then you can just factorize. I'm really hoping this one's nice and easy to factorize. Why did I choose this? Factors are 35. 35 is 5 and 7. Is it working? 7 and 5. Lovely. Negative and positive. All good? The other way is we could have kept it there. I'll do that above there. Are we okay? So I took If you think this is going to confuse you, keep your negative on the left and pull it out if this is going to confuse you. Remember, every mistake of a positive and negative is a loss of 1 mark out of the 100 marks of your exam. And it's not worth losing if you're not sure about the method. You've got to go with the method that you're certain with, all right? So this is concave. X-intercepts are -5 on 2 and 7, and it's concave up in this format. So we've got -5 on 2 and we've got 7. Sorry, I know it's a bad diagram. And where is this? What? Above, less than, where? Less than 0, you want this bit here. Where is it less than 0? From -5 on 2 to 7. Now, what you could have done with that is, just up here, is if you don't want to go taking things over to the other side, you could have just pulled out the negative on this side, and then you don't have to take it over. So if you pull out the negative, you've got 2x squared. What else have you got if you pull out the negative? Take away 9x. Take away 35. And you keep your inequality sign the same. So we've already factorized. You keep that negative out, and we know that that's 2x plus 5x minus 7. So we know that the x-intercepts are -5 on 2 and 7. But this time, so what I've done, you've got two options. Do you take everything over, but make sure you don't mess this up? And once it's like that, if you want to put this on the left, as long as the pointy bit is facing the x squareds. Your other option is to leave it all on the left. Factorize out the negative. Got it? And then do this normal factorization. X-intercepts are -5 on 2 and 7, but you have to draw it this time concave down. You get that? Do you know why you have to draw it concave down? Because it's a negative parabola. Negative in front of the x squared. So now my solution is greater than 0. So do I have the same solution? You should. So where is that parabola greater than 0? From -5 on 2 through to 7. So the main things here, please, if that's a less than, make sure there's less than, not less than or equal to. In the first example up here, less than or equal to, as long as there's equal signs. All right? Okay. That's quadratic inequality. Sometimes the sketch may be drawn for you already, so I might just say solve this. It might be factorized already. Oh, did you get this one? All right. Can you give me a sketch of this? So this is obviously going to be a bit easier. Do you know where your first factor is? Yeah, x-intercepts are 0 and 2. Because x is 2 makes that 0. Concave up or down, be careful. Is this concave up or down? So let's have a look. X bracket 2 minus x. Let's expand it. Or just multiply the x terms. You'll see if it's concave up or down. I get 2x minus x squared. So be careful, that's concave down. It's not concave up. So when you look at that, this, they might say solve this. So yes, I know the x-intercepts are 0 and 2, but is it concave up or down? So just get there like this and expand, and I'm getting a negative x squared term when I expand it. So that's definitely concave down. So with this one, just be very careful if you see them like that. It is concave down. So where's my solution? Anyone? Where is this less than or equal to 0? I'm shading it. What are the x values? Less than or equal to 0. X is greater than or equal to 2. Look, if you were stuck, you know that 2 and 0 are what we call critical points. They will be, or the x-intercepts. If you're stuck, you can always try substitute x is -1 in here and check. If I substitute x is -1, I would get -1 times 3. That's negative. Yes, that is the solution out here when x is -1. If I substitute x is 1 into there, I get 1 times 2 is 2. 2 is not less than or equal to 0, so the solution is definitely not in here. And if I substitute x is 3, I get 3 times -1, and that's -3 is less than 0. Yes, the solution is for these x values on either side. So you could check it by substitution. But if you know how to draw it and you know how to read above and below the axis, you don't have to check anything. Okay? An absolute value equation or inequality or inequation. An inequation is an inequality. So you know how when I showed you the absolute value ones first, we just looked at this first and you said, no, we didn't look at this. An example, if the absolute value equals A, remember you said to me make one positive, make one negative. That's not what we did today. But if you're just solving the absolute value of a function equals A, you just do function of x equals A or function of x is -A. That's what you told me before, right? But today what we looked at, so this is type 1, that's solving the absolute value equation. That's an equation with an equal sign. Absolute value inequation or inequality, that's these, etc. Right, those. So if I'm asking you to solve absolute value of function of x is less than A, so sorry, I know that's not easy to read. So if this is absolute value of function of x. So if I ask you to solve that less than A, where do you go? How do you write this out? So the distance of the absolute value function from the origin is less than A. It's this type. You write this out. How do you know that? You think of it as distance from the origin. So the distance from the origin, that's function of x, by the way. So if you're asked absolute value inequation or inequality, it's got a less than or greater than sign or equals. If it's less than, you say the distance of this function from the origin is less than A units. So that would be from there to there. That's how you write that one out. The other type is if the absolute value of the function of x is greater than A or greater than or equal to A, it doesn't matter. Again, you've got your distance from the origin this time. Is it going to be greater than A? More than A units from the origin. This type is more than A units from the origin. Sorry, I should have written this out before. You would do the function of x is greater than A, or the function of x is less than -A. So these are the scenarios you will get with absolute values. You've got, if it's equal to A, you just do one positive, one negative. If the absolute value is equal to A, you do one positive and one negative one. If the absolute value of your function is less than A, this is the distance of the function from the origin is less than A units, you recognize it as a number line, and that your function lies here between -A and A. And if the absolute value of your function is greater than A, it's more than A units from the origin. So your function is more than 4 units from the more than A units from the origin. It's outwards. Function of x is greater than A, or function of x is less than -A. So the motto here, I'd be drawing it. I would be drawing if you do this little sketch, that will help you. And if you remember that its distance from the origin is more than this, distance from the origin is less than this, it'll help you.